Good afternoon, everybody. So let us start our lecture today. In our last lecture, we discussed a programming primer, right? We discussed about the structure or format of a program, or yes.
Sorry, it's still not showing your screen on Teams. You might need to stop sharing and start sharing.
My screen is not sharing. How about now?
Yep.
Thank you so much. Okay, in our last lecture, we discussed how to implement an algorithm in pseudocode, or specifically, then we discussed skeleton of a program in pseudocode, in C#, in C++, and Java. And we learned how to start a program and then how to print something on console. And okay, so then we started discussing about variable, right? Okay, and although I gave you a homework to practice, how many of you, honestly, please tell me, did not have any chance to practice the homework problem? Can you please raise your hand? You're really busy with other stuff? Okay, if you don't have a chance, I'm asking who did not have a chance to do practice, okay? This class is heavily practice based. I gave an example with a swimming class, right? Swimming course. This course is like a swimming course. If you do not practice, I'm afraid that you may fall behind. Then first 3 weeks will be fine. After that, you will be behind little bit, and ultimately it will be difficult for you to achieve your goal for this course. Okay, so please practice, keep practice every day. Sometimes spend some time. Okay, or at least every other day. Okay. Okay, in my last lecture, maybe I mentioned that I would not teach something. That you remember that what I mentioned that I would not teach in this course? Okay, the one thing that I would not teach English. Then another thing that I told you that I would not teach math. Okay, another thing is that I would not teach, honestly, I would not teach how to run or how to running in the field of programming. Okay, I will teach you though how to walk in the field of programming. Let me give an example. So when we were a little baby, right, our parents taught us how to walk. Right? They did hold our hands or finger, and they taught us how to walk. And similarly, if we have a little baby or any relative, we teach them how to walk. We hold their fingers, right? And teach them how to walk. Do we really teach them how to run? No, not really, right? It's not needed. If a baby is healthy, it is supposed that you or she will be able to run by himself or herself, right? So same thing. In this course, I will teach you how to walk in the field of programming and problem solving, and then it is your responsibility to learn how to run. Ultimately, you have to run, right? This is a race. And this is the starting of a race, maybe a marathon race, and then you have to be self-motivated, especially people who are joining from online. Okay, you have to be self-motivated. As long as you are self-motivated and practice programming, then you should be good. So every day I will give you some homework. You don't need to turn it to me, but you need to turn it to yourself. Assess yourself that whatever you understand, then you will be succeeded. Okay. So you understand. Actually, I will not be teaching how to programming. That I'm simulating with running. Okay, programming means running. Okay, I will teach you how to walk. Walking. Okay. So I gave you a very simple program to discuss this one, right? maybe this program, hello world program, hello world program, this one. Okay, I will give you extra 3 or 4 more programs today to practice. Okay, please practice this before you come in next lecture. Okay, I will come back to this program again. Okay, so in our last lecture we started discussing about a variable. Okay, what is a variable? A variable is a name of a memory location or a chunk of memory location. Okay, a variable is used to hold data. In all programs we work with some kind of data. There is no program that does not deal with any data. Some programs with numeric data, maybe work with binary data or audio, video, everything is data. Your audio, video, movie, song, everything is data, right? So all programs deals with some data. So in order to hold data in computer memory, we need to use variable. Okay, let me give you an example. What is a variable in real life? You have noticed that in the back of each seat there is a tag, it's a chair number. So Carson, you're seat number 41, right? 41. 40? So if this is 40, the next one will be 41, 42, 43 for someone, okay? It is easy to assume that no 2 chairs have same number. This number should be identical, right? Then we usually do in this way. Okay? So how about, we have not hardly assigned, we recommend that everybody will sit in the same place every day. But we have not hardly recognized it. But how about if we hardly assign it, then you will sit only in this place or on this chair. Okay? So then how can you confirm that? One way that you need to take the chair with you, right? And when you come back, you will place your chair over here and sit on it, right? And as an adult person, one person can sit on one chair only, right? Not 2 persons. Maybe there is a baby, there are 2 babies, they can sit in, 2 babies can sit on one chair, but we are considering an adult person. Okay? But is there any way that without taking the chair with you, can we ensure that you will be sitting on chair number 40 every day? How can we do that?
By making sure you remember it.
Okay. Okay. Another way? Yeah, label. There is already label. Okay, but if you next time, what is your name? Please. Yeah. Huh? Okay, if next year Hussein comes here and sit over here, then there is no guarantee, right? That we will not kicking him out. So there's one way that so you will lose your tag number, right? So one way is that when you leave, if you take not the chair, you take the tag with you, right? Your tag number is 40. When you leave, if you take your tag with you, and then whenever you come back next day, wherever you see a chair, an empty chair, you sit over there and put the tag 40. Then you are sitting on the tag number 40, right? Every day I will call you who is 40. Then you will raise your hand, right? This is a way to ensure that you will be residing in, or you will be calling, or you will be recognized by 40. So yes, 40. Therefore, seat 40, right? Okay, its computer memory is organized in programming language exactly that way. Okay, whenever we assign a variable, it gets a name of that memory location. It gets some memory location, and it gets the name of the memory location. Okay, and whenever programs is running out, then the memory space gets empty. And whenever we run the program again, wherever it finds an empty space, it sits over there and put the tag as the variable there. You understand? This is the way computer programs work with variable. Okay, let me give another example. But based on the type of variable or type of data, there are different kinds of variable we use. Okay, some data may be larger, some data may be smaller. Some data may need only one character. For instance, sometimes we say T for true, F for false, right? Only one character it needs, T or F. We can say sometimes say male for M and female for F, right? So we need only one character to recognize male or female. Okay? But sometimes it may need multiple characters, right? For instance, in order to write your address, you need multiple characters, right? Characters and maybe numerics, alphanumeric letters, right? Sometimes if you want to record a song or movie or video, it will take more space, right? Okay, so based on the category of data, there are 8 primitive data types, built-in data types for the most of the programming languages, or especially the 3 languages we will be discussing in this course. Okay, we will go through this for integer data, floating point data, character data, and string data. Okay, string is not a built-in or primitive data type. But let me give you another example. Everybody, we are familiar with parking space, right? So there is a parking lot behind us. You see that there are parking lot over here. Usually, if for a regular private car, one private car takes one parking spot, right? Okay. Some vehicles may need 2 parking spots, right? If it is a large vehicle, you need 2 parking spots, right? Some vehicle may need 4 parking spots, right? But if it is like 26 wheel heavy trailer or truck, it may need 8 or 10 very large parking spots, right? So that there may be hundreds vehicle parked in this campus. But every vehicle is recognized by a tag, different unique tag number, right? In terms of state, including state or maybe every vehicle has a unique tag number, right? So think about that. Whenever we park a vehicle, wherever we get a place, we park there, right? If it is a small car, then we take one place. But if there is a car already parked over there, we do not jump into that, right? We take another space, right? If my vehicle needs 8 parking space, then wherever can we use that 2 space over here, 2 space over there, 2 over there? Can we use that? No. We need to look for a consecutive 8 parking spaces, right? Same thing in computer memory. Whenever you declare a variable, based on the variable data type, okay, some variable takes 1 byte or consecutive 8 bits, 1 byte. Some variable takes 2 bytes, some variable takes 4 bytes, some variable takes 8 bytes. Okay. So what happens whenever we create a variable, then whatever the variable we gave the name, in a memory space there are some spaces, memory, so it is assigned to in a space, any space that is empty, that is not being used. And whenever we put a value to this variable, that value goes to this space. Okay? And whenever program terminates, this space becomes empty. Most of the programming languages have it's called garbage collector. Okay, so they use garbage collector, call the garbage collector to make the space empty whenever program is done. Okay. I will come back to this program. And this slide later, but let me go to the second slide of our I was discussing this slide, module 1 part 2. So today I will discuss module 2 part 1, variable, simple and complex data types. Okay, so if we open it, so now we We are familiar with variable, right? So what is a variable? So let me come back from the backward of this program. Okay, I will come back to the front few pages again. Okay, so a variable is a name of a memory location. What memory? Computer memory. Okay, we do not see the computer memory, so it is inside the computer. Okay, we do not see, but we need to realize and we need to believe in this. Whatever we are talking, some of these terms are abstract, so you need to believe in this. Okay, it is difficult for me to explain you, to show you actual data. Maybe if you have a flash drive or pen drive, right? If it has a movie or a audio or video, if you break it, you will not be able to see it, right? You have to hook up this with a computer or an appropriate device. Then you will be able to see what happened. Okay? So we need to believe in that it has some data. Okay. So a variable is a name of a memory location that is used to hold data. Okay, from our mathematical concept, okay, from algebra, we are already familiar with variable. Remember that in algebra courses, we used variables A, B, C, X, Y, Z, P, Q, R, M, N as variable, right? How did we use a variable? For instance, we wrote an expression. Okay, we wrote an expression, for instance, 2x minus y equal to, say, 5, for instance, something, right? So here we can write that y equal to, then y will be 2x minus 5, right? Okay, I'm sorry. The y will be, let me make it easier. So 2x plus y equal to maybe 4 or 5, no problem, anything. Okay, then y equal to, we say 4 minus 2x, right? Here we say that x and y are variables, right? And here 4 and 2 are constant or coefficients, we say, right? Okay, so in sometimes we say x is an independent variable and y is a dependent variable, right? Why do we say that x is an independent variable? Because we can choose any value on the right side, x, variable x, and then based on the value of right side, we get a value of y for y, right? So based on any value of x, we get a specific value for y, right? So this is why x is called dependent variable and y is called dependent variable. So same thing, variable, we are familiar with variables, but computer variables are used for expressing algebraic expression like this, or also more. Not only for this, also more. Okay. So here in our program, so you see, we will see that we use variable, and there is a rule to declare a variable. There is the normal rule is that we need to declare type first. Okay, this is type, is int is type, then the variable name. For type, then variable name, there can have multiple variables separated by comma. Okay, so see, the name of this variable is called in general name. We can give any name, but not any name. Okay, so like for instance, this variable is like name, our name. So whenever we have a baby, we give a name, right? We give any name, right? Can you give any name? No. Based on culture, based on family, other family member, existing family members, or relatives' names, or based on religion, we use some name and we do not use some names, right? And if it is male, then we give it male boy name. If it is a female girl, then we give a female name, right? Maybe there is no subversive to law, right? If a boy is given a girl name, It is not unlawful, but it's good word, right? Okay. So same thing in our variable. Whenever we want to declare use some data, we will give a variable, and the first restriction is that if there is an existing variable with a name, we will not use same name again. Right? We will, if you have a baby named Carson, his family, his parent give another name for his another sibling, right? Not the same name, right? Okay. So in general, a variable is name is called an identifier. Identifier, that means an identity. Then how do I identify that variable? Okay. So there are some rules or naming convention for variable. First thing is that we cannot. It must start with a character. Okay, a letter. Must start with a letter. It cannot be started with a number. This is why I said S40, not S40. Not I cannot say 40S. I can say S4, I cannot say 4S. Okay? And some languages allows to use an underscore at the beginning or dollar sign, maybe like the language PHP, JavaScript. Some languages use underscore and then what this special sign at the beginning, but most of the languages do not. So we will avoid this, okay? And a variable name must be a single character, single word. If there are multiple words, then we can use underscore in between or use camel case, for instance, uppercase and lowercase, in combination of uppercase and lowercase. Okay? And before we give a name of a variable, all programs are constructed with some keyword. With some word, there is some keyword. All of these are abstract words. So we will avoid this name while give a variable or an identifier. Okay? And identifier cannot be named as a keyword. At this point, we are not familiar with this, all of this keyword, but while going on, we will be familiar with all of this. Maybe we are familiar with main, then we are familiar with void, we are familiar with static, we are familiar with public, right? You see that all of these names are, only one word. Even it has two words, right? Instance of. Okay, so it will be only one word without space, and all are written in lowercase letter. These are the keyword. It generates some program code. At this point, these are abstract to us. We are not going inside. Okay, what happens when you say abstract, when you write Boolean or something? Okay, and these are the C# keywords, almost pretty similar. But these are the C++ keywords. You see, C++ has some, it's older, an older language. It has two words, sometimes separated by underscore. But Java and C# do not have this underscore in the keyword list. You don't need to memorize this list, but need to be familiar. Ultimately, we will be familiar with this. Okay, all keywords are written in lowercase letter. One thing that you remember. Okay, so if I combine a variable name with uppercase and lowercase, that will not be a keyword. Okay, so the naming convention should be meaningful, and by looking the name, it should reflect the data what it uses. Okay, so for instance, if I give name of a variable as total, we should assume that this will hold the total of at least two numbers, right? Okay. If we give a variable name as an average, then it should hold the average of mean of at least two numbers or some numbers. Okay. So these are simple things, but we need to maintain these rules when we declare a variable and we use this. Okay, this is assignment operator. Okay, in some pseudocode format you can write this back arrow, but instead of this back arrow you can use equal sign. This is equal sign, we say in algebra we say equal sign. This is actually not equal sign in math. In programming we say assignment operator. In our next lecture we will discuss about operators and this. Okay. So here S1 is 3. S1 is a variable actually. It has its value with 3 dot 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 and space. This is a string variable, string type. Okay, an object. So let me go back a little bit. So we are familiar with cout, system.out.println. This thing we are familiar with, right? We discussed in our last lecture. Let me go to the next few slides. Okay. In order to declare a variable, we first consider data type. Okay, based on, because some data contains only one character. Okay, some data very large takes more. Some data take one character, it takes 1 byte. Some data takes more bytes. Okay, so there are 8 primitive data types. Okay, that is built-in. Primitive means built-in data types that most of these languages use. Okay, first one is called byte. The fourth one, byte, int, short and long. So it should go byte, short, int and long. Okay, byte. These are 4 siblings. These are used for holding integer data, whole number. Okay, it can be negative or it can be positive, including 0. Okay, if a variable, you declare variable as a byte, it takes 1 memory byte. 1 byte equal to 8 bits, right? So in general, we can say it takes 1 parking spot. Okay? Any question?
Can it only be 0 or 1, or can it be like 2? A byte, you're declaring a byte.
Then if it is a byte, then it takes one memory byte. Okay, then for instance, we will give an example of a parking spot, right? We can park like this parking spot, right? We can park a regular size vehicle, right? Private car. Then if it is short drive, then you will have 2 parking spots, 2 bytes. Okay? If it is integer, then you will have 4 consecutive bytes. If it is long, then you will have 8 consecutive bytes. That's it. There is no more. No more than that. Okay? So in general, for regular purpose, with programming demo, we mostly use integer type. Okay, for the range, for each data type, there is a range. Okay, so what is the largest number, what is the smallest number. For instance, if it is byte, then the smallest number, it will take for byte. I'm talking about byte. For byte, the smallest number will be negative 127 to including 0 to negative 128. Negative 128 into 0 to 127. Okay, so if it is in byte type, then the maximum value it can hold 127. Okay, and the minimum number it can save negative 128 including 0. Then total is 256. Okay, so for instance, and then for short type, so it takes one memory byte. For short type, it will take 2 bytes, so better, larger data. For integer, it will take 4 bytes. For a long, it will take 8 bytes. So for instance, if you want to calculate how many miles, what feet, what inches, light goes in 1 light year. Some scientists may need to calculate that, right? Or 5, or 10, or 100 light years. In order to express that or hold that very large number, so long variables. Maybe in future there will be large numbers. You know that the ancient people, they had only the Roman number system, we know that, right? Roman number system has a limitation. Maybe it cannot calculate or write more than 70,000 something, 69,000 something those type maximum. You know the Roman type. And now people talk about million, billion, right? And maybe like 200 or 2000 years ago, maybe people, they use thousand to express very large number. Now people talk about billion, trillion, right? Okay, so maybe in future there will be large, right? But for now it is fine. Okay, so this among these 8 types, these are for integer numbers, and there are 2 double and float. These are for holding floating point number with decimal point. Okay, and character is to express one single character, like for instance A, and it is expressed within a single code. A, B, C, only one character type. And Boolean type is true or false. Okay, so how many types we got? 4 plus 2, 6, 7, 8, right? These are the primitive data types. Okay, there are other data types, for instance, string. String is not a primitive data type, but it is built in most programming languages. Okay, but it is not a primitive data type. Okay, it is a custom data type, or we say it is a class. So these are the primitive data types. These can hold only one kind of data. An integer type variable can hold only integer data. It cannot hold a character. Right? Or a Boolean type, it cannot hold. Or a floating point, it cannot hold. So, in order to develop modern programs or application, we need to develop our own data types. That we call a class. That is the concept of object-oriented programming. At the end of this course, you will get an introduction to object-oriented programming in the last quarter. Until now, we will discuss this. We will use all these 8 primitive data types and string type. Yeah. I will discuss the string type with the demo program. So far, anyone has any questions so far? Okay. So if we do maybe it should have in our slide, but if we do a Google search about range of data types. Okay, in Java or C++, in same thing it will come. If we do a Google search, so range of data types in Java, you see the byte, it takes 8 bytes, 8 bits means 1 byte, and range is -128 to 127. Okay, and if it is short, then it takes 2 bytes or 8 bits, and then the lowest number will be -3 to 768, and positive number including 0, and the last number will be 3 to 767. And it is integer, then it takes 4 consecutive bytes, and then this is the range. And if it is long, then this is the range. The minimum number is this, maximum number is this, including 0. Okay, this is and there is also, if I can find an image. Okay, there are also range for float, double, all of this. For instance, this is double data type. This is the double. You see this my screen. This is the float. It takes, this is the small value and this is the infinite value, and then for double this is very large number or small number. In order to, for instance, to hold a very large number or very small number, so what is the weight of the coronavirus germ? Maybe scientists are measuring the weight of the coronavirus, right? It is not visible but powerful, right? Because results are our life. So in order to express very large number, short number, so So we use double variable with decimal point. Okay, so Boolean, it uses either true or false. Character, it says in modern language is a Unicode character that takes almost all characters in all human languages, all alphabets. Anyone has any questions so far? Okay. So why do we have so many data types? Actually, we have a few data types, 8 primitive data types, right? So, but with combination of these 8 primitive data types and along with string type, we can create our own data type that we will learn at the last quarter of this course. Okay, a character type. So I like you to go through these slides. Okay, character type hold on only one character, and a character value is enclosed with a single quote. Okay, and okay, if it is more than one character, then we put in double quote and then we say string. Okay, string is quoted in double quote and then it can hold more than one character. Okay, a Boolean takes only true or false value, nothing else. The value can be either literal true or false. Okay, but there is a difference between C++, C#, and Java. In Java, the keyword is used Boolean. Okay, and in C++ and C# these languages use bool. The keyword is bool. Okay, this is the difference. Okay, this is integer type, this is byte, this is long, this is float, double, and double. For instance, these are the variable name. Okay, the convention is that if it is long, then we need to put an L ending L. Okay, and if it is float, then we need to put an ending F. Otherwise, all decimal values are considered as double. By default, is double. Okay, for float in C++ and Java language, not in C. In C# and Java, we use F for meaning float and L at the end. So we will not use long type variable a lot, but we will use float or double or integer very frequently, integer type. So integer type variable takes, I showed you the range, right? Integer type variable takes, this is the minimum number and this is the maximum number. So in our demo program, it will meet our purpose, right? We are not dealing with. Okay, so when we put the value of a variable, we do not need to use any comma. We cannot use any comma, and if it is positive, then using plus sign is optional. But if it is negative, we must use negative sign. Okay. What is wrong in this code? Yes. Whenever we put a value, whenever we assign a value to a variable, we must consider the data type. Okay. Otherwise, your program will not give expected output. It will not show an error message. Maybe I will get that video. Maybe a few years ago, still 20 or 30 years ago, the program was written in C++. So a rocket, a space satellite was launching from the space station from Houston or Florida. Okay, and then after a few times there was an error in data type, and then it lost several $1 million because the issue the program found that there are issues with the data type mismatch. Program did not show an error, but at some point it went out of range. Okay. I will get that video later. Okay, so here the problem is that an integer type variable cannot hold a decimal value. Even if you enforce to put a decimal value, it will take it, but it will remember only 7. It will not remember the decimal point, it will not remember after the decimal point. Okay, and the float type, what is missing over here? We need to put an F, right? Otherwise, we need to put double. Okay, good catch. Okay. There are two kinds of programming languages. One is called static binding programming languages, static type. What type languages? Like what C++, Java, C#, the languages we are discussing in this course, these are static type. What that means, whenever you declare a variable, you first declare data type. There are some languages though, Python, Scala, F#, okay? So some languages they do not require the data type to be declared. So whatever the value it gets first initialization, it holds it becomes that type. Okay. So we are discussing C#, C++, and Java, right? These are type bind. So we need to consider a static type means for compiler will check the type as compile type. So as soon as you write the program, during compilation time, it will check the type. Okay, I have three more slides in this module. Let me go back, then go to the last, then I will come back later. Okay, so there are another kind of data we frequently use in our program, that is called constant. Okay, so in our daily life, we use x, y, z as a variable, right? And we use the constant as a number that is cannot be changed during program lifetime. Okay, in our life we have some constant property or value, right? For instance, our social security number is constant, right? It cannot be changed during our lifetime. Understand? Our phone number is not constant. It's a variable, right? I can throw out my number and I can get another number, right? I can buy phone with this number. Okay, our mother's maiden name, that is a constant, right? We cannot change our mother, right? Okay, we may change our name. So this is why they are in programming languages, we need to use some kind of data that we are not supposed to change during program execution time, during this program time, okay? That we declare as constant. A constant is declared like a variable. It is also given a name, so that people confuse. Sometimes some book also have misinformation that people say constant variable. A constant is not a variable. These are contradictory words, right? A variable is not a constant is not a variable. But you may see that in Google search or read in some book, you may find mistake. This is a constant variable. A constant is declared like a variable, but it is not a variable. Okay, so how do we declare a constant? It varies language to language. So in Java, we use final double. Maybe we sometimes use static final double. Okay, sometimes we say static also, static final double. Okay, these are the extra keywords are used to assign to declare a variable. This is tax rate. Okay, this is a variable tax rate. So if we do not have this word, these two, then this is a variable. Okay, but whenever I have say final, that means I cannot change it. Okay, and in C# and C++ we use const keyword to make it constant. And C++ we also can use define preprocessor. So it starts with $sign. So this is pound sign, right? It's just a pound sign. So these are in naming convention is that a constant is written in uppercase letter so that people recognize that this is a constant. They do not try to change it. But it's naming convention. It is not a violation. You can give a small letter, okay? So whenever we declare a constant, it must be assigned with a value. Otherwise, your program because you cannot change it. When program started running, you cannot change it. So this is why for when we declare a constant, we have to assign its value. This value remains same during its programming execution time. Okay, this is the difference between a variable and a constant. Anyone has any questions so far? No, that's good. So constant is that we declare like a variable, but remember that constant is not a variable. Okay, and the last, okay, this is the summarization page. But before I go through here, the summarization page, I want to come back. Maybe I have gone through only half of the slides. Okay, so here the part 2, module 2, part 1, it was about variable assignments and data types. Okay. One second, please. Okay, so let us now review. Start from here. Now we are familiar with how to declare a variable, right? A variable is a chunk of name of some memory spaces. Okay, we discussed about data types. We discussed about assignment, how to assign values to a variable, right? Using equal sign. And we will discuss now string literals and review printing. We also in our last lecture we discussed printing. Okay, I will come back here. Okay, so I have one thing, number 4 left. Okay, I will discuss this one. So we also discussed program structure in our last class. We discussed character and also string. There should be a comma here. And then variables, we will discuss string soon. Okay, variables we should assign, we discuss constant, we discuss primitive data types. How many primitive data types are there? 8. Is a string a primitive data type? No, string is not a primitive data type. It's custom data type. Okay, we discuss program structure, and we got an idea what is an object-oriented programming that has a class, right? That start with a class that is called an object-oriented program. We will discuss that later. So maybe we discuss this, that whenever we begin a character with 2 forward slash, 2 consecutive forward slash, then that line is called commented. That line is not executed. Okay. And if we have multiple lines to comment out, then we use start this symbol. Okay, start slash star, and then we end with this star slash. Okay, and without some exceptions, in most places programs like skips white space or blank spaces. Okay. Okay, so this is the character strings. A character is a sequence of, a string is a sequence of characters. This red one is a string. A string is a sequence of characters enclosed by double quote. In some languages like Python, you can encode it in single quote, but the languages we are discussing, it must be enclosed with double quotes. For instance, if we say A in double quote, Then this is a string. Here this will be a string. But if we say A is in single quote, then this is a character. Okay, so whenever we put double quote, then we can use more than one character. But if it is a single quote, then we can use only one character. Okay, this is the difference. Okay. So I'm going to string operations on string program. So we know how to print something on console, right? Using system.out.println in the last program we discussed. Okay. Here system represents the operating system. Okay. And out is a console or screen data stream. Okay, and println, it is also as an object or stream, and println is a method or function. In our last lecture we discussed how to detect a method. There's a closing, opening and closing parentheses, right? So this is in Java and C# we use console.writeLine, right? Okay, how this is a method? How do I declare this method? Know that it has a opening and closing parentheses. Okay, there are some characters that need to be used with backslash character, a leading backslash character. Otherwise, they do not work. They are designed with their way. So these are called escape sequences. For instance, we've got familiar with only one thing, \n. \n means it will give a new line, and there cannot have a space between \n and n. It should be close together. Okay, \t is for new tab, \b is for backspace. How do it get backspace? It deletes the previous left side character. Okay. And in order to display print a single backslash, we need to give double backslash. In order to display something within double quote, we need to put backslash double quote. Okay, these are the called escape sequence. You need to study this with the book. The details are in the book. Okay, so do this, and also please practice this program. Practice this program. Okay, so this program, practice this program. It has some, you see that \t, \n, only backslash double quote. Whenever you see this, this is the output of this program. No matter how do I organize this print value in our actual program, output may depend on the use of escape characters. Okay, it will vary. So practice this in 3 languages, both Java, C# and C++. Okay. And then now we are back to variables. So everything we discussed in these slides. Okay. Now I'm giving you homework. Okay, you don't need to turn it to me, but you need to turn it to yourself. And the homework is that there are 3 programs maybe in this slide you will practice. Okay, there are only 3, maybe 3 or 4 programs maybe here, 4 different programs. Okay, please practice this program, okay, in all 3 languages. Anyone has any questions so far? That's good. Okay, very frequently I gave an example of this class with this silly thing, coconut. Okay, I give an example of this course like a coconut. How many of you have made a coconut? Coconut. You like it or not? You love it? How is it? Everyone? You don't like it, right? Okay. So, coconut is a good rice, actually. I like it. Okay, so, but coconut could be a most food. If you grab a coconut and try to eat it like an apple, right? Then that will be worst food in the world, right? A coconut can be eaten, especially a dry coconut. Okay? Or any coconut is dry one. So, an apple we can just wash it and eat it, right? But a coconut we cannot do that. We have to break a coconut, right? Breaking is difficult, and then more difficult part is the shell, right? There's a hard shell. If you can break this shell, then you will get actual taste of this coconut, right? If you cannot break this shell even, before you get this shell, you need to maybe take out the output skin, right? Outer side skin. Then take out the outer skin, then you will get the harder part, and break it and then test it. Otherwise, even until you go to this place, if you try to eat this, you will not get taste. Programming is same thing. In order to get actual flavor of programming, you need to spend some time to be familiar with, to break the hard part of programming, and then you will start getting interest. And once you find the interest in programming, you will see that you will spending hours after hours to solve the problem. You will be spending nights after nights to practice programming. At that point, I don't need to motivate you. You will be motivating yourself. But first time, for the first few weeks, I need to motivate yourself. Or how can I motivate? This course is maybe many students are not coming face to face. They are online, but everybody needs to be self-motivated. Otherwise, exactly this course is like coconut. You need to break the shell of programming, then you will get actual interest. Everybody understand why I am giving you this example? Okay, thank you. So, okay, so in our last lecture, maybe we discussed program example 4, right? Let us go, same thing I did with example 5. So let me go with example 5 with you. Okay. So in our first day of our program, we did have this, like this. We did have this, okay? Forget about this part until this from here. So I'm commenting this out. Forget about this part, okay? So this part I discussed in another section, maybe 1322. I don't need this. If you understand this, then it's good, but for now we do not need this part. Let us go to with this part, only this. These 3 lines. So what will be our output for this program? Anyone can tell us before I run the program? Yes. Okay, the first line will be hello world, then 2 hello worlds will come together in one line or 2 different lines. Huh? 2 different lines because I have line. Okay. 2 different lines, and then it will come Bob was here, right? So if I run this program, it will have 3 lines, and then hello world, and then Bob was here. So here this part is called a string. It is enclosed with double quote, right? So instead of giving this hello world again and again, if I declare a variable like is a variable as a string type, Okay, in C sharp, S is in lowercase. As soon as I put S in lowercase, you see that color changes. Okay, so a string HW hello world, if I say, then instead of hello world over here, if I say HW, then it will do same thing. HW is hello world. Okay, then if I run this program, it will give me same output. You understand? Now here this hello world is enclosed with double quote. This is called a string, and the type here is string. Okay, in C sharp, string S is in lowercase, but you can give uppercase as well as. Even if you give uppercase, it will work. And like in English, we complete a sentence by a period, right? In English, and in programming language, in most of the cases, we enclose a statement by a semicolon. And sometimes, for most of the cases, you need one semicolon, and maybe you can have multiple semicolons. That means these will be like empty lines. These will mean empty lines. It will not give you an error, but it will work. But we should not use unnecessary semicolons if it is not needed. Okay, so this language, this program is called string. Okay, string is a built-in data type, but not a primitive data type. So string has more and many uses. Okay, so this part of the program has some discussion about string. If I get next lecture, I can discuss something if I get time. But if you may want to try yourself, yes, I'm not deleting this. Okay, you can try yourself. Okay, so this statement, this same thing can be used in this is C sharp, right? In Java also. So here you say same thing. You say string HW hello world. Okay, and instead of putting the actual value over here, actual string over here, I can say HW. This is the variable name. Okay. So what will be my output here if I say HW plus this one? Yes, but remember that there is no space after exclamation. Okay, so it will say hello world, it will print hello world, and then without any space it will say Bob. Just right after here it will say Bob. Okay, for now we are skipping this part. If you don't understand this, for now it's fine. Don't. You see that hello world, and Bob is right here, right? Coming here, there no space. If I want to make a space over here, what do I need to do? Huh? Yes, we can do multiple. We can give a space before Bob, or we can add a space over here. How do I add a space? Like this, right? I'm sorry, it is on hold. Maybe the internet issue. Okay, got it back. So then we can give a space. Then after that, we can use add sign. Normally, the plus sign, plus operator is used to add to numeric numbers. Okay, but modern programming languages, plus operator can be used to concatenate to strings as well as, or a string with a number. We have a few more minutes, right? We will discuss this. If you can understand this yourself, that's better. But at the end of this course, we will discuss this. Okay, this part. There are some built-in methods. Since string is a built-in variable, built-in data type, it has some built-in methods we can use. How do we call this method? We use by dot operator, so dot. Okay, and what else? Okay, in Java, S must be in uppercase. Okay, otherwise if we say S is in lowercase, you see that this program is in most compiler, it will not show you any error message. Maybe it can show a message, but if you run this program, it will not compile. It will show an error. So what is the error message or error over here? Can you detect this? Okay. During program practicing, everybody will get some error message. No programmer can say that I did not do any mistake in the program. The program do not show any error message. Okay? Nobody can say. Nobody can say. So, when you are writing a code, I like you to not copy and paste code. Try it. Okay? Do some mistake, and then you will get some error message, and do not get any. Read the error message. Try to understand what it says. Okay? So if you become familiar with 20 to 30 error messages, then you are good. Whenever you become familiar with some error message, some message, okay? Read the error message. And next time, whenever you become familiar with the error message, right? Then whenever you get that error message later, you can solve that, right? You know that where the error is coming from, right? Okay. But many compilers are simple compilers. They cannot give you exactly same exact error. Okay. But you will give a clue. Whenever you get an error message, you will see that your error will come at least at that point or above of those, not below. Okay, so here it is showing you at the arrow sign, right? It is showing you that class string is that it says class string, that is the problem. Okay, it says cannot find symbol. What is symbol? This symbol cannot find string. So if we give it S is in uppercase, then our problem will be solved. Okay, I have 3 more minutes, right? Okay, now everybody be ready that I will give you some homework to practice, and this is the same thing in C++. Okay, so same thing. S is in lowercase in C++. Instead of you can say declare a variable hello world over here. Okay, so everybody please practice this program, and as well as the 3 or 4 programs maybe in this module. There was these modules, and as well as this program. I like you. This is now time to module 2 part 2, not part 2. It should be part 1. But we skipped in our last part 1. Okay. In part 1, no, not here. I'm sorry. Slides. This one is it here? This one. Module 1 part 2. Sorry, it's module 1 part 2. Okay, so it has some programs here. So I discussed last time until this Bob is here, right? And I'm giving you another homework to practice this one with variable, this one now. Okay, it is using variable. Okay, and then this is same thing in C++. This one is C#, then C++, and then Java. Practice this program, and there is another program, this one. If you can try, okay, try it, and if you can do it, then let's do it. Otherwise, in our next lecture, I will discuss how to read the data using keyboard. Okay, this program maybe if you can try, then it will be good. Otherwise, This program I will discuss in our next lecture. Okay, then after that, if you practice these 4-5 programs, then you will be good. You will have a good start. Okay, everybody please complete this homework. You don't need to turn in to me before you come to next lecture. Okay, then we will be good. Then it will be easy for you to understand. Start with module 2. Okay. Anyone has any questions so far? That's good. So people from online, okay, do you have any question? So anyone has any questions? So if you don't have any question, you may leave. Okay, thank you everybody, and thank you so much. You have a good evening. Video.